welcome to join our WasmEdge Community Meeting. And we have two sessions today. The first one is our mentee want to introduce the work he done during the previous mentorship program. And the second session is that we are going to introduce a new maintainer from our previous committer, and because he's doing lots of contribution, so we nominate it as our new maintainer, and we have vote. And yeah, so today is the announcement. And so for the first session, let me introduce our mentee. And so his work is to help us to using the RunWasm program, integrate with our WasmEdge runtime to test the multiple WasM applications on the cloud services. So let me hand over the host to him. And I think you can share your screen and start your presentation.
Hi everyone. I'm Vatsal. Okay, I'll be sharing my screen now. Just a second. Hi, is my screen visible?
Yes, I can see it.
Okay, so let's start. Uh, I'll be presenting the work done during the LLF X mentorship program using Run WasM with WasmEdge runtime to test multiple WasM apps as cloud services. My mentors were Vincent Len and Yi Huang. So let's start with the goals. What were the goals? The first goal being how to configure the WasmEdge plugin system in Kubernetes, and the second one being exploring how to integrate an HTTP service and the plugin system in in a multi-node Kubernetes setup. So let's start with the first goal. Sub goals to the first goal were configuring the environment variables and dynamic libraries, which are just plugin and plugin dependencies, loading paths, and a CI to verify the result. Uh, I have added some knowledge for the lay people who are new to this ecosystem. So what's the WasmNN plugin? It's just a WasM API for performing the ML inference, and it can be utilized as a WasmEdge plugin. Its name derives from the fact that ML models are also known as neural networks or NN, hence the name WasmNN. More knowledge on this site, WasmEdge. WasmEdge is a WasM runtime for cloud-native edge etc. applications, and it has a major role in replacing traditional Linux containers. RunWas is WasmEdge shim. A shim is just a translation layer that, okay, let me tell you in clear terms. RunWas shim allows Kubernetes to run WasM workloads by providing an interface or a translator between the container runtime and WasM runtime so they can communicate effectively. Exemplar, there are shims like WasmEdge shims, WasM time shim provided by RunWasm. There are more shims. Next, we'll see how WasM replaces traditional containers. So here we have taken K3s. It can also be K8s. It's kubelet part specifically. We know K3s uses its own container, and container implements CRI, container runtime interface. This CRI chooses between container runtimes to use either traditional Linux pods or WasM pods, which are sandbox environments using WasM running WasM binary. For WasM pods, runWasm shims like WasmEdge runtime are used, and for traditional pods, OCI runtimes like Run or Rung, Runc are used, crun or Runc. On to the next slide. Benefits to WasM replacing traditional containers. When traditional container technologies like Docker are replaced by RunWasm's WasmEdge container runtime, the image size, its startup time can be reduced to up to 90%, and build times are also often faster in my experience. It also depends on the workload and dependencies, but it's still very fast, which is really cool. On to the next slide, how it was achieved, how the first goal was achieved. We chose to deploy LLaMA Edge's LLaMA API server as WASM pod using K3s for this purpose. I thank my mentor Vincent Lynn's repo, run WasmEdge demo as most of the setup docs for this purpose. For deploying LLaMA Edge's LLaMA API server on bare metal, that is outside the Kubernetes, were already in this repository. Um, I can show you this repository. Most of the docs are here, like on bare metal at least. At last, we ask what our query regarding who was Robert Oppenheimer, and it replies accordingly. So that's about that. On to the next slide. What was done as for the first goal? First, deployment of LLaMA API server. Second, Helm usage for mounts. And third, CI for pod tests. Okay. Deployment of LLaMA API server, how it was done? It was achieved by mounting all the dependencies of the libwasmEdge plugin wasm.so file as listed by LDD to the wasm pod. Wasm pod, I write again, sandboxed environment running LLaMA API server as a wasm binary. So nobody misunderstands what a wasm pod is. So here is the output of the LDD when run on this libwasmEdge plugin wasm.so. How it was mounted, it was nothing out of the ordinary, as a volume mount like this. On to the next slide, there's Helm usage for mounts. We also used Helm. Helm charts are templates used to manage Kubernetes applications using reusable configuration files. Why they were used? Since the volume mounts were many, repetitive, and platform dependent. For example, they were different for platforms like x86 64, ARM 64, etc. So the Helm template was made for cross-platform compatibility. This part can take up a little bit more time, so I'll skip this one till last. On to the next slide till now. For now, the next part being pod tests and CI. Uh, in pod tests, there were pre-request and post-request pod health checks, which were written. They they record the pod status, container readiness, restarts, events, etc. Stuff about the pods in GitHub Actions. In the GitHub Actions upload, there is also service health check, which is same as pod health check, but for services, and a final test summary report, which combines all of the above. As such, the first goal was achieved. On to the next goal. Next goal was configuring the WasmEdge plugin system in Kubernetes and explore. Okay, that was the first goal. The next goal is exploring how to integrate HTTP service and the plugin system in a multi-node Kubernetes setup. For this, there were sub goals. The first one being how to showcase that this ecosystem can be effectively deployed in the cloud. And same as the first one, a CI to verify the result. For this, first a prototype was made, which is a multi-pod WASM demo, which is a modified echo server, and a final deliverable after this, load bell LLaMA demo, which is also modified echo server with load balancer and watcher. I'll be discussing their architectures now. I have opened the multi-pod WASM demo here, I guess. Um, Yes, this is the multi-pod WASM demo architecture. I have got the architecture here also. Okay, so there are two kinds of pods in this cluster, a splitter pod and two greater pods. The splitter pod receives requests to split two names via a node port service and forwards it to the cluster IP service, which acts as automatic load balancer to the two greater pods. They serve the requests, and the splitter pods again concatenates them and outputs the final output regarding that being hello Sherlock and beating spoke. That was the prototype. The final deliverable, which was load by LLaMA's demo. This is the architecture as to that. I hope it's not too small to see, but I'll do my best to tell you what this is all about. In this cluster, there are three kinds of pods, a load balancer, a watcher pod, and these LLaMA API server pods, which have costs. Costs meaning they run two different models. One is a high cost model and one is a low cost model. Okay, so the main attraction here is the watcher pod. The watcher pod is a non-WASM pod. It's a service watcher with sync services every 60 seconds and full reconciliation every 30 seconds with the load balancer pod. Okay, so 10 concurrent requests are sent to the load balancer, which splits it to the low cost service and the high cost service according to the cost. For example, the low cost service has weight 3 and the high cost service has weight 1. So it will maintain a 3 to 1 ratio when splitting the requests. So that's about that. On to the next slide explaining more about this. Referring readme.md of the load by LLaMA's demo to know more about this. Here I have this. Um, I guess this is the one. Yes. Okay, the load balancer and service watcher deal. First of all, the service watcher is there for service DNS resolution and syncing related service data with a load balancer, and it tries to mimic the Kubernetes service management using kubeRS for automated dynamic service registration, deletion, updation, etc. And the load balancer distributes requests. The load balancer distributes requests to the LLaMA servers, running different models in the backend as pods based on the weight meant to be handled by the model. For example, a service pod running a higher cost model is weight 1, and a service pod running a lower cost model with weight 3 gets to handle more number of requests. That's about that. There is also some future work regarding this project because this service watcher is still a non-WASM pod because it uses kubeRS and K8s Open API, which have hard dependencies on these grades, request hyper Tokyo, socket 2, etc. Although WasmEdge provides grades like Tokyo WASI, request WASI, hyper WASI, etc. But kubeRS is has to be patched itself because these WASI crates, these folks won't link with it without patching kubeRS itself. So it's a bit of a work, but can be done. So that's why it's in the future work. Back to the slides. CI and pod tests. Here also there are pod tests. There are three tests which test three stages of for the pods. The first one being pre-sequential test, the second one being a post-sequential pre-concurrent test, and third being post-concurrent test. Let's first see what these sequential and concurrent tests are. Sequential test is 10 queries asked in sequence, where each query waits for the previous one to be served completely. In GitHub Actions, the average response time for this is 25 seconds for each query, of course. And as for the concurrent test 10 queries are asked at the same time, and average response time here is 200 to 300 seconds. So what this pre-sequential test checks the state of the pods prior to the sequential test. Three pods, three kinds of pods: the low cost, high cost, etc. backend pods, the load balancer, and the watcher. The post-sequential pre-sequential test is the same for this state, the post-sequential test state, and the pre-concurrent post-concurrent test is for the post-concurrent test state. Let's take a look at the test report that it generates to know if this even works or not. Here is the test report, I guess. Okay, 1 second. This one is the test report for the load LLaMA's demo. It records the services, their states, pre-request, post-request, and post-concurrent, and pod states, with also pre-sequential, post-sequential, and post-concurrent. I think I misspoke the earlier one, but they were also the same. So here, for each pod, here there are two high-cost pods and three low-cost pods. Here you can see there are three low-cost pods, which are all normal as for this running, and at the end it also nothing out of the ordinary. It also records the ratio, how the request was split. For example, here they were 1 to 9, and in concurrent test they were 2 to 8. That's next. We saw the final report. Next, pod logs with diff for debugging and test logs. This I'm discussing this part because setting up the load balancer pod with the watcher pod can be hard sometimes. What this does is the load balancer pod logs are recorded before the sequential test, and it is and their diff is taken with the load balancer pod logs after sequential test, and a marker is put there. Uh, Again, the load balancer pod logs are also recorded after the concurrent test, and a marker is put there. As such, there are three markers which are useful for debugging purpose. I can show you if that this works here. This is the yes LB pod logs combined. You can see there are three markers here. The first one being pod logs pre-sequential test. Second one being pod logs post-sequential test, pre-concurrent test, and the third one being pod logs post-concurrent test. Purely for debugging purposes, not strictly necessary. Where would we? Okay, we were here, the pod logs, and as such, the second goal was also achieved. Actually, I guess I've missed showing the CI final test report for the first goal, where we were deploying the LLaMA API server in Kubernetes. Here it is, I guess, somewhere around here. For the first goal, here, it is a similar test report. Mm, Records the services, their states, uh, and the test summary, whether the test was passed or not. So that's about that. Uh, that would be concluding our this presentation. Impact. Okay, we are also discussing the impact of this project. This project tries to demonstrate a real-world scenario as to how WASM workloads can efficiently replace traditional container, VM, Docker, etc. approaches of cloud deployments. Also demonstrated our LLaMA Edge's Rust-written AI API servers to run on the edge. In my opinion, these are the two of the biggest tech leaps of this decade and should become the standards of the respective fields. As for a more practical side, This work can also fill in the LLaMA in Kubernetes documentation, which is here around here, and it says coming soon. This work can fill up this documentation. And thanks for your time. I've also written a blog on this. Please give it a read as it explains more about this on this project and give you more insights on your project if you choose to dive into this ecosystem. Thanks. That's it from my side. Okay.
Okay, thank you so much. Your presentation is, pretty well and to describe the whole your works during the mentorship. So thanks you again to being one of our community member here. Okay,
Thanks.
so let me share my screen now. Hold on, I find. Oh, will you please post your blog post link to the chat? Here's somebody want to have it. Okay, so today I'm going to introduce our new maintainer, which is the Han Chao, and or you can call it George, of course. If you want to reach him, you can just use this GitHub link to contact it. And uh, let me share some of his previous work or previous journey with us. So in the beginning, he's one of our LLF X mentorship mentee. Okay, and he brings the neural speed, one of the WASM neural network backend to us. After his working after the mentorship, he still give us lots of pull requests and implement and improvement our what's the neural network backends, including the stable diffusion. So you can not only run an LLM model with us, you can ask us to generate a photo with your prompt for you. Also, he spends lots of time to integrate the MLX backend, which is a framework to run the AI models on Apple devices. So he can leverage the Apple silicons, leverage the Apple GPU to do the acceleration to make the model run better and more faster. And the last thing he did before is that he also bring the ChatTTS, which is a framework allow you to send your text and it will generate the voice for you. So after bringing lots of uh, features to our backend, he already is one of our WasmEdge committer. And after the very long journey of his contribution, we nominate will be our new WasmEdge maintainer. And we believe with his join, and our community will become more strong and have more uh, different kinds of focus to enhance our community. Yeah, so this is my short introduce to our new maintainer. And at the end, I also want to mention that there is a way or is uh, a way to join our communities, not only become one of the contributor after you submit and interact with our community to bring new features, to bring the improvement, or to reflect the current code base. You can find a contributor, become a reviewer, because you have more knowledge and know how to make this whole project better. And after that, you continue to bring more, more works, more contribution to us, and we will, to try to promote somebody from our reviewer to the committer. And now, if you still, contribute to the whole community um, to not only, bring these new features, but also you will try to lead somebody from the lead somebody or guide somebody, and to bring them from outside to join our community. You can become a mentor. You can become, any different kinds of role in our ecosystem. Not only, contribute the code only. You can contribute the documents. You can contribute the bloggers, or every kind of contribution are all welcome. And we, after your, all of these, we will try to promote previous committer to a new maintainer. So there is a role of the promotion works. So yeah, so this, I hope with this I can just, uh, to describe a way that fun how to fund a single contributor become a maintainer. And Hangwen today is one of our new maintainers. That's why I am going to make this announcement. Yeah. So I believe this is whole of our sessions. And if there is no more question, I would like to, end our community meeting here. And of course, thanks again to our, our speakers to bring their, the Ron Wazi, the very cool project to us. Yeah. So thank you, everybody.
Thank you.
Hello, I have a quick question, if that's okay.
Oh, sure.
Yeah, of course. So just to introduce myself, I'm basically a PhD student working on software test generation mainly. So we have some fuzzing efforts running on different WebAssembly runtimes. So I just wanted some advice, and we found many bugs using different techniques. Just wanted some advice about if there any preference about what parts of the runtime, or the different offerings of the project should we focus our fuzzing efforts on, that would help the community and the project itself.
Oh, okay. So because WasmEdge is a runtime to run the WebAssembly programs. I'm not sure what kind of fuzzing you did, but if you are trying to, generate WASM application program and try to run with us, then it's fine. I believe there are already several teams helping with us, including we are using the OSS fuzzing from the Google tools. And also there are, I believe, 2 or 3 university, they are running their fuzzing tools with WasmEdge and other WASM runtime to test the different kind of program. And I'm not sure if you are doing something like this, because we have another different team that help us to generate a workload to use the Kubernetes with the WasmEdge to try if there is any workload will fail us. So yeah, I'm not sure which kinds of part are you working on?
I see. Thank you for the explanation. So we're mostly trying to target any necessary parts of the system. We're trying to focus our efforts on that. Are there any documentation about the current testing efforts and fuzzing efforts on the repository?
I'm not sure if we already have the document to talk about yet, but maybe you can create an issue on our issue board, and I can share some links or data after this meeting because I don't have a page here right now.
I see. Okay, thank you. That answers my question. And of course, thank you for arranging the meeting.